Hi students, in previous videos we study about electric charge and Coulomb's law. Now in this session we are going to study about electric field. So before starting electric field, we would like to know what is field. You might have heard gravitation field. This you already studied in 11th standard. For example, we can take gravitation field of Earth. Now what is gravitation field of Earth? So we consider that it is the space around Earth where any other object is present, then Earth will pull it. So field is a space around particular object. In gravitation field, it is space around particular mass in which if another object is coming, then that particular object will be attracted by the mass. Similar way आप लोगों ने एक्सपेरिमेंट किए होंगे कि सपोज हमारे पास एक मैग्नेट है, हमने मैग्नेट को टेबल पर ऐसे प्लेस किया हुआ है, तो हम ऑब्जर्व करते हैं कि टेबल का पर्टिकुलर रीजन मैग्नेट के अराउंड का एक ऐसा पर्टिकुलर पार्ट होता है जिस पार्ट में अगर हम आयन फीलिंग्स को रखते हैं या आयन के और कोई छोटे से ऑब्जेक्ट को रखते हैं या इवन दूसरे मैग्नेट को प्लेस करते हैं, तो ऐसे सिचुएशन में ये मैग्नेट जो है उस पर्टिकुलर आयन फीलिंग्स को या आयन के ऑब्जेक्ट को अट्रैक्ट करता है. अगर हमने यहाँ पर एक स्मॉल मैग्नेट प्लेस किया है तो वो स्मॉल मैग्नेट का अट्रैक्शन या रिपल्जन हो सकता है. लेकिन सपोज ये मैग्नेट से बहुत ही दूर हम कोई एक दूसरे मैग्नेट को या आयन फीलिंग को प्लेस करते हैं, तो ये मैग्नेट इस पर्टिकुलर ऑब्जेक्ट को, मेटालिक ऑब्जेक्ट को अट्रैक्ट नहीं करता है. इसका मतलब क्या हुआ कि ये पर्टिकुलर मैग्नेट ने अपने आसपास का एक पर्टिकुलर रीजन ऐसा बनाया जिस रीजन में वो अपने फोर्स की इफेक्ट को जनरेट करता है. दैट इज कॉल्ड इट्स फील्ड रीजन विच इज मैग्नेटिक फील्ड. सिमिलर वे अर्थ अपने आसपास जितने रीजन में ग्रेविटेशन फोर्स जनरेट कर सकता है, दैट इज कॉल्ड ग्रेविटेशन फील्ड. सो सिमिलर वे इफ वी टेक a charge, suppose we take a point like charge, then point like charge will also create electrostatic force in certain region around it. For example, suppose we have one positive charge Q. This charge is called source charge because it is generating electric field around it. It has created some electric field in particular region. So if we place any other small charge, positive or negative, then that will be repelled or attracted by this particular charge. But if we place charge over here, then it is not attracted or repelled by this particular charge. So we can say that this particular charge is out of the electric field of this particular charge and this charge is inside electric field. So electric field is region around charge where if another charge is present, then it will be attracted or repelled by source charge. Now if we define electric field as a physical quantity, so physical quantity has some proper definition to find out its value and direction. So generally electric field is represented by capital E, and electric field is defined as electric force acting on a charge. Electric field is equal to electric force acting on a test charge or a small charge per unit charge. So E is defined as F upon Q. So we can write that force acting on the charge particle is equal to charge particle, magnitude of charge, multiplied by electric field at that point. So this is definition of electric field. Now what is unit of electric field? So by this definition, electric field is equal to force per unit charge. force is Newton and charge is Coulomb. So its SI unit is Newton per Coulomb, or we can write volt per meter. So sometimes this unit is also used. Now see, this is actually basic definition for any type of field. Generally, field is defined as force divided by its cause. For example, if we write gravitation field, so gravitation field is gravitation force divided by gravitation force cause is mass, so it is divided by mass. Similar way, if we write electric field, then electric field is electric force per unit charge, so it is the force acting per unit charge. Now what will be dimensional formula of electric field? So if we write dimensional formula, then electric field is electric force divided by charge. Dimensional formula of electric force is m1 l1 t minus 2 divided by charge, that is a1 into t1. So if you simplify this, that is equal to m1 l1 t minus 3 and a minus 1. So this is dimensional formula of electric field. Now electric field will be vector quantity or scalar quantity. So its definition is electric force per unit charge. So obviously electric force is vector quantity, that means electric field is also vector quantity. And generally for positive charge, electric field is considered outward direction. For negative charge, it is in inward direction. So this was about electric field. Now electric field depends on which factors? So first one, electric field depends on distribution and quantity of source charge. Whether it is point charge, two charge system, it is continuous charge system. So electric field depends on quantity and distribution of source charge. Source charge means the charge which is producing electric field. And second one, it depends on the position of a point where we need to find out electric field. So हम इलेक्ट्रिक फील्ड कहां पर फाइंड करते हैं, वो भी एक इंपॉर्टेंट पैरामीटर बनता है. अब इलेक्ट्रिक फील्ड की डेफिनेशन में हमने फोर्स एक्टिंग पर यूनिट चार्ज लिखा हुआ है. तो यहां पर इलेक्ट्रिक फील्ड फाइंड करने के लिए हम जो भी चार्ज को प्लेस करते हैं, दैट चार्ज इज कॉल्ड टेस्ट चार्ज. टेस्ट चार्ज स्मॉल q. टेस्ट चार्ज is by definition unit positive charge which is placed at a point to find out force acting on it, so that we can obtain electric field at that particular point. But actually suppose we have one positive charge q which is source charge and it is generating electric field around it. Suppose we want to find out electric field at point P. So what we will do, we'll place a small positive charge here. This positive charge will create some force on this positive charge and we'll observe that force. We'll measure the value of force and direction of force. Now what we'll do, we'll take ratio of that particular force and this charge, so that we can obtain electric field produced by this charge at this particular point. But if this charge is not negligible, then it will also create its own electric field around it, and that may change the orientation or arrangement of source charge. So actually or practically, we take this charge as minimum as possible or negligible. So actual definition of electric field should be like this. Electric field is equal to limit of Q tends to 0 force divided by Q, and it is depending upon the position, so we write it is as a function of R. So this is actual definition of electric field. Now, is the electric field reality or just geometrical or mathematical representation? So practically electric field is reality. There is a space around particular charge or particular mass where if another charge or mass is placed, it is always interacted. So what is importance of electric field? तो सबसे पहले इलेक्ट्रिक फील्ड से इलेक्ट्रिक फोर्स के कैलकुलेशन जो है वो बहुत सिंपल हो जाती है. जैसे हम एक एग्जांपल लेते हैं. सपोज वी हैव वन पॉजिटिव चार्ज हियर 1 कूलम. It is creating some electric field around it, and at distance 1 meter from this charge, here suppose we got the value of electric field, and it is equal to E is equal to suppose 9 into 10 raised to 9. This is value of electric field at that point, Newton per coulomb. Now suppose we want to find out force acting on 1 microcoulomb charge placed over it. So in that case we can directly use formula F is equal to Q multiplied by E. So this is equal to 1 into 10 raised to minus 6 multiplied by whatever value of electric field we obtained. Suppose we are placing some another charge here 5 microcoulomb negative, and we want to find out force and interaction. So we know positive charge was repelled, but negative charge will be attracted. And what will be value? So this is 5 into 10 raised to minus 6 multiplied by E. So electric field at particular point will not change till we keep the source constant and we keep the point same. Now how this is useful? So we can compare it with gravitation field. Suppose this is earth and we are placing one object on the earth, surface of earth, or we can draw figure like this. This is table and we have placed one object on it. Now we want to find out gravitation force acting on this body in downward direction. So we always use mg and not F is equal to G me m upon re square. Actually this is formula of gravitation force acting on this body due to earth. But we know this value is gravitation field created by earth, and that is always constant. We write is G into m. So similar way, this formula is widely used when we know value of gravitation field. Similar way, F is equal to Q into E. This formula is widely used if we know electric field due to charge system at particular point. So in that case, we need not to use this formula. F is equal to K Q1 Q2 upon R square. So this is useful concept of electric field. Now electric field is reality. We know that particular charge exerts force on another charge where it is kept at certain distance. But can we know after how much time force will act? For example, suppose charge is placed here, another charge is placed here. This will attract this charge. But after what time? So that concept we can obtain by electromagnetic field concept. So electric fields or electromagnetic field of accelerated charged particles are traveling with the speed of c. So time delay can be explained by electric field concept. So electric field is reality and not just mathematical approach.